Hello students, this is Bhushan Pawar sir. Today we are going to discuss the topic of matrices. So before going in detail to the topic, let's go first of all to the introductory part. That is the introduction of the matrices. So we start with the definition of a matrix. Now what is a matrix? So it is a rectangular arrangement of elements in rows and columns enclosed in the square bracket, or sometimes we can use the round brackets. You got the point? It is a rectangular arrangement of elements. Okay, now a matrix has m rows. You know the meaning of rows. They are the horizontal lines. So if we write the elements in row wise like this, okay, horizontally, so that is called as row. Okay, and if we write the elements vertically, so that is called as column. So I mean to say that this is row number 1, this is row number 2. Okay, this is column number 1, this is column number 2, column number 3, like this one. You got the point? Okay, fine. So if my matrix has m number of rows and n number of columns, then order of a matrix, very important term, order of a matrix is m into n. And what is the order? So it gives the idea of number of rows and number of columns in a particular matrix. And m into n, this gives the number of elements in a matrix. Okay, next. Matrices are generally denoted by A, B, C. Means whenever we want to denote or want to assign some name to the matrices, we usually represent that name by capital letters A, capital B, capital C. And small letters are used as an element of a matrix, whereas capital letters are used as a name of a matrix. Clear? Okay. Now matrices have some different types, and they are defined based on different parameters. So one of the most important parameter is based on the row and column. Okay, so if my matrix has only one row, so that matrix is called as row matrix. Okay, I have given an example. We can see this matrix has only one row. We can say only one row, whereas this matrix has 1, 2 columns. So I can say that my matrix has an order of 1 into 2. So in general, the order is denoted by 1 into n for a row matrix. You got the point? Okay, fine. Now we go to the next one. Now it is column matrix. What is that? As I said earlier, a row matrix has only one row. So similarly, column matrix has only one column. Okay, here little bit change. In the row matrix, order is 1 into n. So here for column matrix, order will be n into n. Okay, that is, in the row matrix we have only one row. So in column matrix we have only one column. Am I clear with this point, all of you? Okay, now we go to the next slide. Again, a type of matrix, it is called null matrix or zero matrix. So this matrix is defined on basis of the elements. So if my matrix has all the element as 0, you got the point, every element must be 0, then that kind of matrix is called as a zero matrix. It is denoted by O, capital letter O, as the name suggests, always denoted by capital letters. I have given an example. Even we can have the matrix, zero matrix can be also represented like this one. So whatever the order of a matrix we have, the most important part is that each and every element must be 0. Then that kind of matrix is called as zero matrix. Okay, then again based on the order, okay, we have a square matrix. Now as the name suggests, square. Actually, you know one thing, when we draw matrix, we draw like this one. Okay, now if I can join this brackets like this one, so looks like a rectangle. Okay, So if the rows and columns are not equal, so m into n, okay, that is the order of a matrix. If m and n are not equal, then that matrix is called rectangular matrix. And if m and n, that is number of rows and number of columns, are equal, then that matrix is called as square matrix. Okay, that is the definition given as the first point. Okay, so in a square matrix, number of rows and number of columns are always equal. So we can have different orders, like we can have 2 by 2, we can have order of 3 by 3. So what is the meaning of 2 by 2? My matrix will have 2 rows and 2 columns. Okay, what is the meaning of 3 by 3? My matrix has rows 3 and columns 3. Okay, now next point, that is this point, the elements a11, a22, a33. Remember one thing, usually the elements are denoted by small letters. And what is this 1 1? So the first number indicate the row number, second number indicate the column number. So when I say a11, so I mean to say element a from first row, first column. Okay, then a22 means element from second row, second column. A33, that is element from third row, third column. So these are called diagonal elements of matrix. Okay, now why diagonals? Because when we draw a square matrix like this one, so this elements, okay, looks like this line looks like a diagonal of a square matrix. Hence those elements which are on this diagonal are also called as diagonal elements of a given matrix. Okay, now what is important part is that diagonal elements are defined only for a square matrix, because in the rectangle matrix we do not have a diagonal. Okay, in actually geometry part we have a diagonal in the rectangles also, but in matrix terms, okay, in the definition or in the field of matrices we don't have diagonals for the rectangular matrices. Okay, next point, that is this one. What is this? It says elements aij where I is not equal to j are called non-diagonal elements of a matrix. Means those elements which are denoted by these dots. Okay, so obviously looking at this diagram we can clearly say that these elements are not on the diagonals. Hence this, for these elements I is not equal to j, and if I denote any element by aij in general, so I represent the number of rows and j represent the number of columns. Okay, so when both the numbers are equal, they are called diagonal elements. See here, 1 1, 2 2, 3 3. So I mean to say I and j both are equal, they are called diagonal elements. When they are not equal, that is I not equal to j, they are called non-diagonal elements of a matrix. You got the point? Okay, fine. Then we have some properties, like when we need to find the a square. Okay, so what is the meaning of a square? So to find a square we have to multiply a with again a. Is it clear? So for squaring of a matrix, never square the elements. Square of a matrix means the matrix multiplies itself again. Similarly, if I want to find a cube, how do I find? So it is a multiplication of a square with a. And if I want to find a cube, I should do the work of a into a into a. Clear? Okay. Then similarly I have some laws of indices which are applicable for the matrix field. That is a power n plus 1 can be written as a raised to n into a. Remember that law of indices, a raised to m plus n. Okay, the same is applicable here. See, I have written over here even this one. Remember the one thing, these properties are used for JE also. Okay, for JE and even for CET and examinations, this kind of definition or the applications are asked. Okay, so any doubt for this kind of points? Okay, let's move to the next one, diagonal matrix. Now remember one thing, here these are the specific matrices which are classified on the basis of elements only. Okay, now onwards, whatever matrix we have, that is a square matrix. Now listen here. So this is a square matrix, this is the diagonal, so those elements which are on the diagonal are called as diagonal elements. Okay, now those elements which are not on the diagonal are called as non-diagonal elements. So suppose I have a matrix whose non-diagonal elements are 0. Okay, now the question is about this diagonal elements. So suppose I have a case in which diagonal elements I have written over here 2 3 4. I have given an example also over here, right? What very important part is that these diagonal elements are not equal, then this kind of matrix is called as diagonal matrix. You got the point? It is called as diagonal matrix. Now suppose what I do here is that I just cancel these elements and replace them by elements which are equal. Okay, so in the diagonal now I have same elements, so this kind of matrix is called as scalar matrix. Is it okay? Okay, it is called as scalar matrix. Okay, so that is the next slide. A diagonal matrix in which all the diagonal elements are same is called as scalar matrix. Just now I had given an example. So remember one thing, every scalar matrix is a diagonal matrix, but every diagonal matrix need not be a scalar matrix. Okay, now the next one, again kind of a scalar matrix. Remember scalar matrix in which it was a diagonal matrix in which all the diagonal elements are equal, but what if all the diagonals are 1? You got the point? In that scalar matrix all the diagonal elements were not 1, they were not 0, they were not 1. Other than 0 and other than 1, if I have 2 3 4 5 6 7 8 9 so on as the diagonal, so that kind of matrix is called as diagonal matrix, sorry, scalar matrix, if all the elements are equal. But if all the elements of a diagonal are 1 unit, then it is called as unit matrix or identity matrix. Usually they are denoted by I, capital letter I 1. So I mean to say that all those matrices nothing. Okay, leave it. Next one, every identity matrix is a scalar matrix, but every scalar matrix need not be identity matrix. Again, very important part. Okay. Next, now we have important part again. This will be used for our calculation also. It is called as upper triangular matrix. Now what is upper triangular matrix? Just try to learn from this example. I have a given example in which I have a scalar matrix whose order is 3 rows and 3 columns, means 3 by 3. So these elements are diagonal elements. Okay, now what we find is that below this diagonal we have 3 elements, but all the 3 are 0. On the upper side of triangle, upper side of diagonal, we have 3 elements, but at least one is non-zero. Okay, I won't say all the non-zeros, but important is that at least one should be non-zero, and we can have a structure in which this is also possible. Okay, but still it is called as upper triangular matrix. Okay, you got the concept. Upper triangular matrix is a matrix in which every element below the diagonal is 0. So this kind of matrix is called as upper triangular matrix. So we have one more point, we can have lower triangular also. See, here we have concept remain the same. We have a diagonal element, okay, below diagonal non-zero, upper side of diagonal 0. So that is called as lower triangular matrix. You got the point? I hope when you revise all these things, so this will be totally in your mind. Triangular matrix. So a square matrix is called as triangular matrix if it is an upper triangular or lower triangular, means any one of them. It's not necessarily it should be upper or lower. If any one of them is possible, it is simply called as triangular matrix. The very important part, diagonal matrix, scalar matrix, unit matrix, null matrix, all these kind of matrices are also the examples of triangular matrices. Okay, now we have one more slide of transpose of a matrix. Now what is a transpose? So suppose we have a matrix. I have an example over here. We can see over here that in the matrix A, the first row is 1 3 minus 2, second row 1 4 0, third row 2 0 3. Now suppose what I do, I interchange rows and column. Is it okay? Is it clear? What I did, I have interchanged rows and columns. Means what? The row element will be written as now column elements. See, the first row is now written as first column. Okay, second row written as second column, third row is now written as third column. Okay, so this kind of matrix which is obtained by interchanging rows and columns of a matrix is called as a transpose of a matrix. How do we denote it? So suppose matrix A is my original matrix, then transpose of a matrix is written as A power T. T is in capitals. Okay, you got this point? Okay, so remember this transpose of a matrix, it is obtained by interchanging rows and columns. Very simple part. Now these are the properties of a matrix which are also important for J concept. Property number 1, transpose of a transpose gives again an original matrix. Now suppose I have two matrices of the same order. Remember, they must have the same order, because if the orders are not same, addition is not valid. Okay, hence the matrices A and B having the same order, then A plus B transpose can be written as A transpose plus B transpose. Now suppose I have a scalar K belongs to R, means it's any scalar value. So if it multiplies to A, then we take a transpose, then it is equal to K into A transpose. Means first you multiply by K, then take a transpose, or you first take transpose then multiply by K. It's one and the same one. Okay, it is one and the same one. Now suppose next point, we have two matrices, they are multiplying, so we get a matrix AB as multiplying matrix. Now after multiplying these two matrices, the whatever answer we get, we take the transpose of that matrix. So it is AB the whole transpose. Okay, now suppose B transpose, we find the transpose of B, and then we find the transpose of A, then we multiply. So AB transpose is equal to B transpose into A transpose. So this is called as the property, very important property, also called as reversal law of matrices. Okay, everybody got this concept clear? Okay, now